Alright, welcome back to another Python programming tutorial, and today we are going to be discussing what is a collection. Um, Yesterday I recorded both the array and list video, and I think it would be a good idea before I continue with all the various collections that exist in Python to just discuss the idea behind what a collection is and discuss some keywords that describe collections. I think it'd be just very beneficial for us to kind of go do like kind of a broad overview of it all, and then have these videos that kind of go into the nitty gritty of each collection and really show like their strengths and weaknesses. So let's first off start by defining what a collection is. So a collection is a group of data or datum, which is the plural for data, stored under a single variable name. So an array is a great example of a collection. A list, a set, a dictionary, and a tuple are all examples of collections in Python. And pretty much every programming language that I've ever worked with, and most programming languages that I'm aware of, have some sort of collection data structure or data type inside of the programming language or the software development kit. So it's very common to use collections in your software development journey and experience. Now, let's go ahead and talk about some keywords and then look at an example. So I'm just going to create a simple array here, call it array or R, and an array here would be denoted by the two braces here, and then an array is an homogeneous, meaning all the same data structure or all the same data, and we'll have, I don't know, Nate, right? So this is an example of a collection, right? Now this is one type of collection, but it's still a collection where you have a group or multiple datum here being stored under one variable name. Here you have multiple data under one variable, and that's what makes this a collection. Now let's go ahead and talk about some keywords here that you're going to be hearing me refer to not only in the arrays video but also in other various videos as well. So the first one is homogeneous versus heterogeneous. Homogeneous data structures mean that all data inside of the collection have to be the same data type. So an array is an example of a homogeneous data structure where all the data stored inside the array has to be the same, or it's not an array. So you'll either have all integers, so this would be an array, right? Or you could have all floats, right? It doesn't really matter. As long as all of these datum are the same, then it's an array, right? And now we would also call that a homogeneous data structure where all the data inside of the collection is the same type of data, right? So that's an example of an array. And then obviously if that's not the case, where let's say I have an int here, I have a float here, and then I have a boolean here, and then I have a string here, this would be called a heterogeneous data structure. This is where all the data is different, or not maybe all of it is different, but they're not all the same. Right, so they are the same or not all the same. And in this case, this is heterogeneous, meaning that they are not all the same and that you have some different values here. So here I have a string, a boolean, a float, and an int. Definitely not all the same. In this case, this wouldn't be an array anymore. This would be a list, and that has a heterogeneous data structure. So again, that's the first key terminology that I'll be using is homogeneous versus heterogeneous. Homogeneous, same data. Heterogeneous, different data, right? And the greatest example I can give of that is an array versus a list. All right, so the next word that you're going to hear me say a lot is the idea of whether a data structure is ordered or not. So what does that mean? Ordered means that every element inside of the data structure or the collection can be indexed, essentially, and that it follows a specific order, as I'm sure you probably guessed, right? Now, something very important to note about the Python programming language, and is pretty much the standard in most programming languages, is that everything is zero based, meaning that you count starting at zero. I'm going to say that again because it's very important. You count by starting at zero. It's the same in JavaScript, Java, C++, and a multitude of other languages as well. So this would be considered the zeroth element of this list, then this would be the first index, second index, and third index. So although there are 4 specific elements in this list, it counts 0, 1, 2, 3, which is 0, 1, 2, 3, 4 things, right? So that's something to keep in mind. That's what it means for something to be ordered, right? And later, you'll see in these videos that we'll do is I'll pull up like list 1 and I'll index a specific item inside of, for example, this list by typing in its position inside of the list. So this would be a good example where this will print the 0th element here by typing in this index value. So I'll print Anthony to the console window just like so. And that's a very good example of how this is ordered. A good example of something that's not ordered would be a set, which would be something like this. So if I made a set, for example, this is unordered, meaning that you can't index these values in the same way. So if I tried to do the same thing with now this set, and I'll rename this to set now so you can see, I will get an error because sets are unordered. So that's the next thing, is the idea that things are ordered or unordered. All right, the third idea is duplicate elements. Certain things, like a set, for example, don't allow duplicate elements, and if you try and perform specific operations on the set, for example, like a union, you will get an error if there are duplicate elements inside of the set. So although you may be able to print the sets and do, maybe some of the minor operations with the sets, it is not a valid set, and you won't be able to do, for example, like the symmetric difference of the sets if you have a whole bunch of duplicates, because obviously like it's going to be confused. So that's something to keep in mind. Certain data structures and data collections will allow you to have duplicates and certain will not. For example, a tuple can have duplicates. And then the last concept and the last word I really want to cover is the idea of something being immutable. Immutable is the same as can't change. So an array would not be immutable. In some languages it is, but in Python it definitely is not. And so let's go ahead and look here. I'll create an array, name it A for array, and I'll have, I don't know, 1, 2, 5, and 10, right? And then I'll go ahead and create a tuple, which is another type of collection. It'll have the same type of data in it. So this is a very good example of immutable versus not immutable. The array here is not immutable, meaning that I can change it. I can add elements, I can remove elements, I can clear the entire thing. I can do a multitude of methods to this array to change it, update it over time. But I cannot do that with a tuple. If I wanted to do that with a tuple, I would actually have to change it to an array or unpack it. One of the two would work. And then after I do whatever I want to do, I would have to change it back to a tuple. So let's go ahead and look at this in real time. I'm going to go ahead and add an element to the array. So I'm going to do a.append, and I'm going to add 12 to this, and then I'm going to print a. And you'll see this will work just fine. And we'll go ahead and add 12 to the end of the data structure here, which you can see printed right here. But if I try and do this exact same thing with t here, and you'll even see that it will actually have the add method here. It'll actually pop up with the IntelliSense here. Let's try and get it to pop up again. There it is. If I try and add an element here, let's say 12, and I'm going to go ahead and print t, I will get an error because tuples are immutable, meaning they can't change. And as you can see, it says can't do that because you can't add to tuples. So that is the idea of immutability. That is a word that is a computer science fundamental, and I strongly recommend that you learn what that means. But essentially it means that you can't change the data. So once you create the tuple, it is what it is. If you want to change it, you have to typecast it to a list or an array or a set or a dictionary, and then go from there and then change it back to a tuple. So anyways, that's just the very brief introduction into the idea of what a collection is in Python. And the last thing I'm just going to touch on are the 5 collections that are used. So the very first one and the most basic collection used is called a tuple. A tuple is a data structure that is immutable, meaning you can't change it. It is ordered, so you can index it, and it does allow duplicate elements. And it's denoted oftentimes with this parentheses here. So this is a good example of a tuple. The next one is an array. An array is not immutable, meaning you can change it in Python. However, it has to be homogeneous. By the way, tuples are are heterogeneous. They can contain multiple datum inside. But an array is homogeneous, meaning all the data has to be the same. They are not immutable, and they are ordered, meaning that you can access them with indices. And that goes the same for tuples. Tuples are ordered as well as arrays. Then the next one is a list. So we had a tuple, an array. The next one is a list. A list is pretty much the exact same as an array, but it's heterogeneous. So an array has to all be the same data, where a list can have different types of data inside. So for example, if I change this to a string, that array that was stored as A is now a list. So you have a tuple, you have an array, and you have a list. The next one is a set. A set is something that is unordered, meaning that there is no order to it. It's denoted by these two braces here, or you can type in the keyword sets and put two braces like, or two parentheses like so, and essentially you have this collection of data. Sets are unordered, so they have no indices. So if I went S and tried to index the 0th element, it would not work. Sets are unordered, and very important, if you want to perform the various operations like union, symmetric difference, intersection on a set, they cannot have duplicate elements. Very important, sets cannot have duplicate elements. So again, just recapping, we have a tuple, an array, a list, and a set. And then the very last one is going to be a dictionary. A dictionary is very similar to all of that I just said, but it has key value pairs. So for example, I can create a key like this, and I can set that to a value. And then whenever I want to index that value, I type in the dictionary's name, two braces, or excuse me, two brackets, and then I type in the key name, which was name in this case. And I went and print this to the console window, it would print whatever that key was holding. So in this case, it would print Anthony because that's stored under the key name. So when I type in the dictionary and then do a pointer to the name, it gives me the value contained by that. And that is the idea of a dictionary. So those are the 5 collections that are used in Python. Again, that's a tuple, an array, a list, a set, and a dictionary. And each one of them have their own distinct advantages and disadvantages. So that's it for this video. If you found this video helpful, please leave a comment below, and I'm going to go ahead and now create some tutorials diving into each one of these data structures. So I will see you all in the next one.